Hello everyone, welcome back to this coding tutorial. Here today we'll be creating a particle simulator using Python. So we'll be combining the power of Pygame for creating our simulation and then the Matlab used for a real-time data visualization. So let's get started. First, let me create the main.py. Let's start importing our libraries. So first I'm going to import Pygame. So before we do that, we just have to go to the terminal, then install pip3 install Pygame. So I think it's already installed here. So this is the framework library used for our Pygame. And now this Pygame is used for our main simulation window and handling the user input. Next, let's import NumPy as NP. So NumPy will help us create efficient numerical operations. And then let's import Matplotlib.pyplot as PLT. So Matplotlib's pyplot module is for creating our plots, and then from Matplotlib.animation import func animation. So this func animation from the Matplotlib will help us create an animated plot. Now let's go to the code line by line. We save. So first I'm going to have this pygame.init. So this line initializes all the Pygame modules, and it always is the first function when we call this Pygame. So next we'll have width and height set. So here we are setting up our Pygame window using width and height. These are the user variables. So I define it to be 800 and 600. So the window size would be set to 800 cross 600 pixels. Next we have the screen Pygame.display set mode. Here I have width and height. Next we have Pygame.display.set caption. Particle simulation. So here we are setting up our Pygame window. We define the width and height, create the window with these dimensions, and set the caption to particle simulation. Next, let's create an empty list called particle. And then we have max particles set to 200 or maybe 100. So here we are creating an empty list to store our particles and set a maximum number of particles to prevent the simulation from becoming too slow. So I just set it to 100, can be 50 or can be 10 or anything you would like. Next, let's define the color. So I'm going to use black and red. So these lines define the color tuple for black and red, which we'll be using later for drawing. Next, let's create the Pygame clock object, which will help us to control the frame rate of our simulation. Pygame dot time dot clock. Okay, and then let's set up our MATLAB figure. So we create a figure and axis. So let's create figure, axis, plt dot subplot, figure size set to 6,4. So this is where we set the axis limits to match our Pygame window. So let's set the axis limit. Set xlm equal to 0, width, and then ax set y limit to height, 0. And then let's set the title of the axis. Set title to average particle position. Now let's create an empty line object for our plot. Line equal to ax dot plot. Let's create the list. So we create an empty line object for our plot and initialize a list to store the average position. So this is also a list where I want to store the average positions. Now let's create a function that adds a new particle to our simulation. So we define the method called add particle, and if length of the particle is lesser than the max particles, then we enter this if condition, then check if the particles dot append, and in here we are going to define the positive using the array pos t type equal to float, neg is going to be p dot rand n of 2 times 2. So this function is going to add a new particle to our simulation. So it takes a position and creates a particle with that position and random velocity, but only if we haven't reached the maximum number of particles. So if we have reached the maximum number of particles, we just don't enter into this loop. Now let's create a function to update the position of the particles. So we have defined update particles. So I create a for loop p in particles, p of positive plus p of velocity. Now this it move when the particle hits the wall, so it have to bounce back, so it has to reverse its velocity when it is when it hits an edge. So to do that, we have to bounce off walls here. So first I have this if, where I want to do it for the direction when it hits the width. So if it is going to the maximum width, then I reverse the velocity, and then similarly I do it for the height. So these are the actions I want to perform when the ball or particle hits the wall. Next, let's update the function for our Matlibplot. So define update plot person frame. So here if particles, then enter average position np dot mean for p in particles, comma axis 0. Then we have average positions dot append average position x data equal to positive for pos in average positions, y data equal to for pos in average positions, line dot set data x data comma y data, then axis dot relim and axis dot auto scale view. Then we have to return line. So this function will update the plot. It calculates the average position of all the particles added to the list of average position and updates the plot and adjusts the plot view in the x and y as a x and y axis. So now let's do our animation part. So let's set up our animation. So I'm going to create a func animation object that will call our update plot function. So for that I have anim equal to func animation figures. So I'm calling the update plot function, set the frames, interval, and the split set true. So here and then we show the plot window without blocking. So we are plot dot show does this without blocking. So I set block variable to false, and now let's move on to the main loop. So running this variable is set to true, so I'll be using this as a flag. Next, inside the while loop I'm going to use this running until keeps running, create event for different events. So I'm going to manage all the mouse clicks, adding particles and all the events into this while. So first is I'm going to create an event like whenever the user quits the game. So I'm looking for that particular event. So I use this for monitoring the event quit. If event dot type equal to pygame dot quit, I set the running as false. Okay, some indentation. So the first event is done. Next, let's move on to the next if else, which is event dot type equal to pygame dot mouse button down. So whenever the mouse button is clicked, I call the add particle mouse dot get pause. Next we have to update the particles. So I'm using this function call here, and I'm having the screen fill to be black. Next, let me use this to draw particles. So for that, for P in particles, pygame dot draw circle, pass screen, make it red. Then we have pause dot as type integer 5. We have pygame dot display dot flip and clock tick set to 60. Now let's update the Matplotlib using plot.pause. So first I'm using update particles, then I draw the particles, then update the display, and then we give the matplot to update. Next we also use this while when we quit. So we use pygame.quit, and then finally we close the figure. So this quit is just to clean up quitting the Pygame and closing our matplot figure when the simulation ends. Let's run the code. So I have a warning here. I think in line 30, so I think I missed a comma there. So now let's run the program. So I have a warning in line number 37. So this is okay. I think the for loop and the if loop should come inside the for loop. We try again. Okay, so it says itself dot set xlim not callable. Okay, I think this one is supposed to be without the equal to. Now I think I should be able to run. Okay, so we have two windows. So first window is the particle simulation window, and the second window is the Matplot to plot our real-time simulation. So let's release a particle by clicking the mouse button. So now I have released a particle, and a particle's position has been plotted here in the real time. Now let me release another. Okay, let me release another plot. So this is how it moves in. So we can release n number of particles and see the position being tracked. So I think this is the application for creating our particle simulator. I hope you liked this video. Do give a thumbs up and subscribe to our channel. Thank you.